Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So I have 5 to the power of x plus 5 to the power of x is equal to 7. Now, 5 to the power of x here, because this is here twice, I'm simply going to factor this out from my left-hand side. So now I have 5 to the power of x times, now 5 to the power of x divided by 5 to the power of x, well, anything divided by itself is simply 1. So I have 1 plus, again, 5 to the power of x divided by 5 to the power of x is 1. So now I have 5 to the power of x times 1 plus 1 is equal to 7. Now we're going to simplify what's in the parentheses. 1 plus 1 is equal to 2. So I have 5 to the power of x times 2 is equal to 7. Now we want to go ahead and isolate 5 to the power of x, so I'm going to divide both sides by 2 so I can move 2 to my right hand side. So then these two would cancel out, and I would have 5 to the power of x is equal to 7 over 2. Now what I'm going to do is I'm going to take the log on both sides. So now I have log 5 to the power of x is equal to log 7 over 2. Now, an important property of logarithms is that if I have something in the form log a to the power of b, I can actually move this exponent b to the front of the logarithm. And so this would be equal to b times log a. And the reason this property is so important is because let's say we have 7 to the power of x is equal to 9, right? So I'll first start by taking the log on both sides. So I have log 7 to the power of x is equal to log 9. And then I can actually move this x to the front by using this property. So then I have x times log 7 is equal to log 9. And then I would divide both sides by log 7 to find the value of x, because now x isn't an exponent, it's a real number. So that's why I'm using this property on 5 to the power of x is equal to 7 over 2. So I'll first take the log on both sides. Log 5 to the power of x is equal to log 7 over 2. And then I can move my exponent here to the front. So now I have x times log 5 is equal to log 7 over 2. Now, if I have something in the form log a over b, another important property of logarithms, this is equal to log a minus log b. And also, if I had something in the form log a times b, this would equal log a plus log b. So in this case, we aren't going to use the second property. We are going to only use the first property, which is log a minus log b. So in this case, a would equal 7 and b would equal 2. So now I have x times log 5 is equal to log 7 minus log 2. All right, so now to solve this problem, what I'm going to do is I'm going to first start by isolating x, because we obviously want to isolate x to find the value of x. So now if I divide both sides by log 5, these two cancel out, and I will be left with x is equal to log 7 minus log 2 over log 5. Now, to actually continue with this problem, I have to actually plug in, or I have to use a calculator to find the values of log 7, log 2, and log 5. So now if I plug these values into my calculator, I get log 7. This is equal to approximately 0.8451. Now log 2, this is equal to approximately 0.203. Oh, sorry, that's not right. 0.3010. And finally, we have log 5. And this is equal to 0.6990. All right, so now all that's left is to plug these values into our original equation. So I have x is equal to log 7, which is 0.8451, minus log 2, which is 0.3010, divided by log 5, which is 0.6990. Now 0.8451 minus 0.3010, that is going to equal 0.5441. And we still have this divided by 0.6990. And finally, 0.5441 divided by 0.6990, that is approximately equal to 0.778. Now, to check, our original equation was 5 to the power of x plus 5 to the power of x is equal to 7. Now we have x is equal to 0.778. So now if I substitute an x, or 0.778 for x, I get 5 to the power of 0.778 plus 5 to the power of 0.778 is equal to 7. Now, 5 to the power of 0.778 is approximately equal to 3.5 plus, again, 3.5 is equal to 7. Now 3.5 plus 3.5 is 7, so I have 7 equals 7. Because this is right, our solution is right. Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 3x to the power of x is equal to 3 to the power of 3 to the power of 3. Now what I'm first going to do is I'm going to take the power of 3 on both sides. So now we have 3x to the power of x to the power of 3 is equal to 3 to the power of 3 to the power of 3 to the power of 3. And if we have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3x to the power of x to the power of 3, well, this is equal to 3x to the power of x times 3, which is simply just 3x. And this is equal to, now, a to the power of m to the power of n, this is also equal to a to the power of n to the power of m. because essentially both of these are equal to a to the power of m times n. So they can change places. So right here we have 3 to the power of 3 to the power of 3 to the power of 3, and this can be written as 3 to the power of 3 to the power of 3 to the power of 3. And now, if we have something in the form a to the power of a is equal to b to the power of b, then this means that a is equal to b. As you can see here, 3x to the power of 3x, both of these are the same. The exponent and the base are the same. And same with here, 3 to the power of 3 to the power of 3 to the power of 3. The exponents here are the same. Meaning, this would equal 3x is equal to 3 to the power of 3. Now, we can either do this in two ways. Our first way is doing 3 to the power of 3. Well, 3 to the power of 3 is 27, so we get 3x is equal to 27, and if we divide both sides by 3, this cancels out, and we get x is equal to 27 divided by 3 is 9. Now our second way is 3x is equal to 3 to the power of 3. Second way is just simply dividing 3 at the start, and 3 to the power of 3 divided by 3, well, this is 3 to the power of 1, and if we have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So 3 to the power of 3 over 3 to the power of 1, this is equal to 3 to the power of 3 minus 1, which is simply just 3 squared. And for our left hand, these cancel out, and we get x is equal to 3 squared, and 3 squared is 9. So we get x is equal to 9. So that's our second way.